Okay, so we're gonna solve this problem, and from solution initial value problem from Webwork. So we have this differential equation, and we're gonna try to find a solution of the form e to the rx. Okay, so why we do wanna try to find a solution? So we look for a solution of the form y equals e to the rx. Okay, so you'll see that that the what happens is the e to the rx is gonna, because it's exponential, the derivatives is just gonna be the same function times a constant. So if we do minus 12y, we get minus 12 e to the rs. If we do minus 4y prime, that will be minus 4 times the derivative of y prime. So what is y prime? What is y prime? There you go. So this is r times e to the rx. And then the next one will be second y prime. So what is second y prime? Second y prime is, there you go. So this is r squared e to the rx. So turns out that if I do y prime, second y prime minus 4y prime minus 12y, if I add that the whole thing, what do I get? If I this one plus this one plus this one, what do I get? 0, because that's the equation, right? So if I add all these guys, I got r squared e to the rx minus 4 r e to the rx minus 12 e to the rx. So any ideas? What would you like to do now? So what do you think we want to? So the question is in the problem, right? So the problem is saying, so try a solution of the form for some unknown constant r by substituting to differential. So I think we need to plug in probably that substitution. We do it. Simplify and factor the equation in the previous part as much as possible, and then find all values of r. So really the final goal here is find an r that is going to be solution of the equation, right? So we want, what is the purpose? Find r. So what do you like to do? I need to solve this equation by r. So what would you like to do? Yeah, I simplify what? No. Yeah, but tell me, I will gonna, what I'm gonna factor. Yeah, so I factor e to the rx, then I go r squared minus r minus 12, right? And now what should we do? What can we do? Second, we can factor. Mm-hmm. We can factor, that's true. Okay. Okay, so we factor the polynomial, right? So mhm. Positive or negative? Yeah, that's true. Yeah. So so we can factor, or how else you could solve this. That's one way. What could be the other way? Yeah, and then how do you can solve this? Mhm. Yeah. So how do you solve that by for r? Quadratic formula, right? So you could use quadratic formula here. So but this one is nice. So you can do 2 minus 6 is minus 12, and then so that's a way factorization. So now you have 0 equals e to the rx times this times this. So from calculus 1, you know that if the multiplication of three numbers or two numbers is 0, one of them has to be 0. So from here, you conclude the following. You have e to the rx is 0, or r plus 2 equals 0, or r minus 6 equals 0. So what do you think? Well, okay, these are good, right? So r equals -2 and r equals 6. Now e to the rx equals to 0. What can we do with that? No, this one is doesn't have no solution because exponential goes like this. So it never touches 0. So this one does not produce solution. So no real solution. So we forget about it. Other thing you could do from the beginning is I divide by e to the rx, both sides, so I cancel it. You see, you could say I divide by e to the rx, and then I had to solve this quadratic formula, so I use quadratic formula. But you need to recognize that this is never going to be 0. Okay, so either way, you have to mention this is never 0. So we have -2 and 6, so those are our answers. So let's plug in the solution here. It's -2 and 6. Okay, -2 and 6. We have to submit the other thing. Oh, it's kicking me out. Oh, maybe because I'm going to my other computer. I'm sure if that is happening. -2 and 6. Oh, they don't like the semicolon. Find all the if there is more than. It's a comma? Okay, thanks. Okay, so that's the answer, and as we know, so I just show you the solutions. That's what we did over here, right? So we plug in, simplify a factor, your equation, as much possible. Be sure you divide out any factors guaranteed to be non-zero. So what they want us to do here is this part. Divide by e to the rx, and then you divide by e to the rx, then you got this guy gone. So you got r plus 2 times r minus 6. That's what they want. These steps are just to make sure you just don't plug in the answer in a computer or something. You can just do r plus 2 times r minus 6. That means you factor and simplify. So they want you to first plug in the whole thing. So over here, that's what we have over here. The first part, they want this r squared e to the rx minus 4r e to the rx minus 12 e to the rx, and that's what they're showing over here. R squared e to the rx minus 4r e to the rx minus 12 e to the rx. Then they want you to factor e to the rx and divide by e to the rx to simplify, to get the quadratic formula, basically. Okay? Yes or no? Oh, okay. Okay, so we can keep going, right? So you just plug in this, okay. So let's see what other problem we have here. I mean that one is easy. Do you guys you need to show that y equals cosine t is a solution of this. Do you guys need help with that or not? So we do show that y cosine of t is a solution of this, right? So this is 1 minus y squared. This is 1 minus cosine. I guess we can put cosine of t squared, right? This is 1 minus y squared. So what is the derivative of y with respect to time? Negative sign. So when we make it a square, what do we get? Sine. So we got negative. So it's basically sine squared, right? So we can copy this. So this is sine squared equals 1 minus cosine squared. Is this formula right or not? Oh, but yeah, but okay, yeah, but negative is positive, right? So it will just become positive sign, right? So had you seen this formula before in trigonometry, right? So this formula is right, therefore this is a solution for this guy. So you are using trigonometry to verify that this is a solution of this. Okay. So that's what you mean. I mean, anything can be the test. I mean, that's what is in the homework. So, so I give all these problems because I will take problems from I will take the problems from the for the exam from there. But this is just trigonometry, so it's just like how can you verify this is a solution? Because right now you cannot solve it. So why is this interesting? This is interesting because is this linear or non-linear? What do you guys say? This is linear or non-linear? This equation. Non-linear. So we solve a nonlinear equation thanks to trigonometry. So as I said, it's very weird when we can solve a nonlinear equation. So this is a very special case, that because we have the most famous equation from trigonometry. Okay, so another problem. I think this is similar to what we did. I make a video of one of these problems yesterday. So please check. Somebody asked me, not sure if this problem. Yeah, though I think it was that problem. This problem was similar. So the last one. Oh, this one actually this is separation of variables. So you actually this problem should be here. Shouldn't be here. I'm gonna eliminate it because it's separation of variables. I mean, you can solve it, but it's supposed to be for separation of variables. So that problem I'm gonna take it off. So far we discussed everything, right? So let's go to the next one. Uh, the last question is separation. I mean, you can solve it, but it's separation of variables. So it does not make part of this section because this section is second. Oh, sure. But that's what we're gonna do next. Yeah, but yeah, let's do it. No, but let's do it. I mean, it's fine. It's separation of variables. So that's what we're gonna do in the next. So it's dAdt AA. Okay, so we got. Let's see if I can see. Oh, it logged me out. Yeah, it looks like I cannot be at the same time in two different computers in Webwork. It's kicking me out. So I'm gonna write it down here. dAdt. Let me write here in my notes. dAdt equals AA. A0 equals 2. Okay, so let's go solve it here. So this is new section, basically separation of variables. Okay, so I'm gonna do this is a new section. So I make a video yesterday because separation of variables was the method was kind of missing half. I don't know what happened. So, but that now is complete. So separation of variables. That's the section we're gonna do now. Separation of variables. So this is your first method. So we haven't done anything yet. So we just have been understanding how to verify that something is a solution of a differential equation. So when you have an equation like this, the ADT, A0 equals 2, that's a typical differential equation. And good news, applications are most like this. Okay? So the applications we're gonna see like a population of growth population of a bacteria, a cooling law, Newton's cooling law, circuits are very similar to this equation. So what I show in my video is that we have dy dt, and we have a function, let's say h of y, g of x. This separation of variable is, you just can rewrite this equation as 1 over h of y dy integral. Oh, sorry, I put dt, so let's put t here. So you move the dt to the other side, and then you got gt dt. Okay. So that's separation of variables. Okay. And people in engineering do it all the time, and you just, I justify why it's okay to do this in the video. So go ahead. So take 1 minute and apply this formula to this equation, and try to integrate to see what do you get. Okay, so tell me how I'm gonna transform this thing. I'm gonna have equal, and then what? What I'm gonna have on the left hand side. Say again? Yeah. Yeah, so let's put it like 1 over 8a. And on the other side, dt, but basically there is a 1 right here, right? And now we integrate. So let's start easy. What is the integral on the right hand side? T. Let's call it plus c, right? And what is the integral on the left hand side? What is it? Yeah. So we take the 1/8 out of the integral. So basically that will save us on headaches. 1 over a, I take it out, and then I got ln of a. So almost correct. How can we fix it? What is missing? Hmm? Absolute value, right? So this one, don't forget the actual value of this baby. Okay. And then yes, you wanna be very serious, you can write a of t just to show you're serious. So now what should we do? What is our purpose here? What do we want? Do we want to solve by? So we want to have an expression like a of t equals to something. That's what we want. So we need to solve this. How can I solve this by A of t? Yeah, there you go. You multiply times A, then you go AT plus AC. You don't worry about this AC. I mean, at the end, you just, a constant times 8 is just another constant. So you don't worry about those constants. Nobody cares. And now, what can I do? No, you don't say multiply. You say you take the exponential in both sides because it's a function, right? So you take the exponential on both sides, and then what? Exactly. So this exponential and the ln cancel each other. That's a property that you saw in calculus. You saw that e of ln of x equals x, right? This is a property of calculus you saw. So I told you you will see all these properties of calculus. So now you have a of t equals e to the at plus ac. Now, do I want this absolute value? That's important. This is important. You are not gonna see this trick on the book. You're gonna, if you don't read the whole book, you might miss it. Okay, so that trick is important. So how can I eliminate the absolute value? So we don't like absolute. Say again. So we don't like absolute value because absolute value is like this. So absolute value is not differentiable at 0. So whenever this thing is gonna, it might have corners, so we don't have, cannot find derivatives of this. So the trick is the following. So look at this. So is the power of the constant. So we have e to the at times e to the ac, right? So I have absolute value of at equals e to the at times e to the ac. But the absolute value, what it does, if basically depending on the value of t, a of t is positive or negative, right? So actual value of at is telling me is a of t if a of t is positive, or is minus a of t if a of t is negative. So basically, I just have a problem of plus or minus, right? So what I'm gonna do is, this is just a constant, so I'm gonna call it another constant. Or basically, I have a problem with plus or minus, right? So I'm gonna call it plus minus. Okay, I'm gonna eliminate the absolute value. And I'm gonna say this is plus or minus e to the ac e to the at, right? So this plus or minus is depending basically of the constant, okay? But you know, this constant is anything. A times c is a constant, e to the ac is a constant, plus minus e to the ac is a constant. So I just call this whole thing a new constant. And then I don't have to worry about this. So a of t is k e to the at. And that's the answer. Okay? So so
The K symbolizes the plus or minus?
yes. But so basically that's the problem is gonna give it to you. If you say oh, I think we have a0 equals 2, you see? So my whole problem is, when do I choose positive or when do I choose negative? Well, this initial condition is gonna tell me if k is positive or negative. Okay, so that we are not done. I thought we were done. We need to solve now a0 equals 2. So when we got a of 0, we got, what do we got? When I plug in t equals 0, I get k. And a0 equals 2, so k is 2. So my solution is a of t equals 2 e to the at. Okay? And that should be my answer. Let's see. E2 times e to the at. So, looks like 2 times e to the 80. So I guess I'm not going to eliminate the problem because I just solved it. So it's initial value problem, separation variables. So this is probably the most basic but the most fundamental problem of for the first order differential equations. We're going to solve all the applications basically with this the same way over here. Okay. So what I need you guys to move on because we need to work on the applications. That's gonna be my lecture on Thursday. Only applications. Okay. So let's go to the other separation of variables. Separation of variables. Okay. So problem one. Yeah. Well, problem one. Let's start with something else. So this one, I think we did this. This is very similar to the one we solved. I solved in the video. So I'm gonna skip this one. This is the same thing, and I mean I don't wanna do this. Somebody wants me to solve this one? You're fine? Yeah, okay. So they're kind of the similar trick. This one is probably more interesting. This one is more, yeah. So okay, let me say something. I mean, we solved. Just watch this video, okay? I saw a video. I make a video but very similar for the first two. These two are very similar to the one that I made in video yesterday. Somebody in my office hours asked me. I did it. It's on the Blackboard. So now let's do this one. So this one. So this one is y prime equals xy plus 5x plus 3y plus 15. So try to think about 1 minute, otherwise it's not fun. So try to think 1 minute, what would you do? I mean, it's separation of variables. So that means this guy, xy plus 5x plus 3y plus 15, has to be the multiplication of two functions. One is dependent of x and the other is dependent on y. So think what could you do? I'm gonna write it down here on my screen. dy dx equals xy plus 5x plus 3y plus 15. Xy plus 5x plus 3y plus 15. Yeah. So ideas. What can we do? Factor. Yeah. What could I factor? Uh, So we're gonna do the following. So on this part, we're gonna factor x, and get y plus 5. And in the other one, what could we do? Factor what? 3. Let's factor 3, so I get y plus 5. Okay, go ahead. What will you do now? So go ahead, write it down in your notes. And also, you should see when you watch my videos, please try to solve the problem first. So you are watching the video, stop the video, start solving the problem to see where you got stuck, and then you complete the video. It's probably the best thing to do. At least for the second video. The first video probably you wanna understand. But so what will we do? What can we do now here? Mm, so remember, I want something like dy dx because this is separation of variables. Gx times h of y. So what could you like? What could be h of y? Okay, y h of y plus 5. I agree. So what will be g of x? X plus 3. There you go. Because this is factorization. How do you factor xa plus 3a? How do you factor that? So it will be a and then x plus 3. So look at this. Who is my a here? My a is this big guy. So I factor y plus 5 and then I got x plus 3. Okay? So now I do separation of variables and that will be easy. So sometimes you have to do something about this to make it separation of variables. So what will be the next? How yeah, so 1 over y plus 5 dy equals x plus 3 dx. Now integrate. So now what is gonna be the integral? What is the integral on the left? Mm, no, we can integrate this guy right away. How can we find that integral? Yeah, yeah, that's the antiderivative. This is ln of the absolute value of y plus 5, and the integral on the other side. Yes, plus 3x. Yes, plus 3x plus a constant, and the constant is for both of them. Okay, but now uh, what do we do now? Because I need y, right? Yeah, exactly. We do the same thing, same trick. Exponential, and then we cancel this guy. We got absolute value of y plus 5, and then we're gonna have the same trick than before. This is e to the c times e to the s squared divided by 2 plus 3x. And now what? How can I eliminate the absolute value? You just do this. Y plus 5 equals, there you go, plus or minus, e to the c e to the s squared over 2 plus 3x. Okay. And now this is just a constant, right? So you don't care about that one. So you get y equals k e to the s squared divided by 2 plus 3x minus 5. And that's the solution. So y equals k e to the square divided by 2 plus 3x minus 5. So let me well, let me, so you remember, right? So it was k e to the square divided by 2 minus plus 3x minus 5. That's correct, right? That's what I put over here. Yes or no?
Yes.
Okay. Okay, let's let's move on then. Other one. Mm, this is easier. This is just to test your understanding. If x of t equals k, find the value for k for which the constant function xt equals k is a solution of this differential equation. Go ahead. So I give you a minute to think about this. So you need to plug in xt equals k in the equation.
For the top part, you had 4, the t to the 4.
Yeah, it's t to the 4. So somebody got an answer? So how do we do this? So we go, uh, what is the derivative of x with respect to time? If f of xt equals k, what is the derivative of x with respect to time? Hmm? What is k? Is k a constant or a variable? A constant. So what is the derivative of a constant? Zero. So this guy is zero. So I have minus 4k plus 5 equals to 0. All that I have to do is solve by x. So I'm gonna get, if I'm not wrong, 5/4. That's it. Just to test that you know how that you are not scared with the xt's, and this is just a constant. So you when you plug in, this is 0, and then you just get. Yeah. This is not this is actually this problem not separation of variables. It's more like plugging in, but anyway. Say again. Oh, because when I plug in all that I had to do is plug in the x of t. That is a constant, right? So when I plug in here, the derivative of a constant is 0. So this k must satisfy the equation. So I need to solve minus 4x plus 5 equals to 0. So I got minus 4x minus 5, and then x equals 5/4. And that's k. Yeah. Okay, so let's go what else do we have here. And then this is similar to the ones we have been doing. So I'll let you, the y-intersect is 6. So you need to know that, yeah, at x0, y is 6. Okay, that's all you need to do. And plug in. And this is also similar. Let's see, dy.
Yeah, y is 0, you're saying it has to include time, right? Because time would be good with 0.
Sorry, let me check. This one. So yeah, y-intercept. So y-intercept is 6. So that means y-intercept is 6. This is 6. So this point is really 0, 6. So you have the condition y0 equals 6. So it's another way to say y0 equals 6. The y-intercept is 6. So you need to solve that equation. Y0 equals 6. So solve this equation with y0 equals 6. But I'll let you try it. I mean, this is similar to the ones we have been doing. You know, this is almost very similar to the one we did on the other section at the end. 28. Yeah. Let me see. I mean, this is also similar. We can solve one of those. This is similar to the one we just did too. Yeah. Okay. This one you move the y minus cosine x to the other side and then factor cosine of x. And then solve. So let me see, we do this one. Let me see other problem. Yeah, this one usually, this problem is solved in my notes. Okay, so you can see it in my notes. You have to do partial fraction. Maybe we'll do this one in the final review. Probably I'll do that one. I don't want to do that one yet because it's the one before. I don't want to do it yet because you guys need to warm up. So you'll be scared when you see that one. I'll solve it in my notes. And this one, yeah, this one probably more interesting. Maybe we're gonna do this one. 10. And this, yeah, this one is fine. This one is fine. Yeah. So let's do this one over here. Oh no, this one. Otherwise, all the problems are very similar to the ones we had done. I mean, maybe a little thing, but you know, that's kind of the thing. You have to sit down and wonder a little bit, but then you'll find the solution. So let's do this one. We're gonna solve. Okay, so I write it down here. We're gonna solve this problem. So this is 7 plus x to the 12 dy dx equals x to the 11 y. So we move y with y, x with x, right? So we get y dy, then x11 dx over 7 plus x to the 12. And now we integrate. This is separation of variables. So what is the integral on the left? And this problem was 10. Sure. So problem 10. Now, after this one, I will do some applications because that's what is more important for me right now. So you guys start doing the applications. So we started. Okay, we have 30 minutes, right? Okay. So what is the integral on the left? This one, y squared over 2. Now, how do we do the integral on the right? No, this is 11. No, so what? So you can use substitution, integration by parts. Which one you wanna use? Substitution.
Equal 7 plus x.
There you go. So we do u equal 7 plus x to the 12. So what will be the u? If this is u, what is the u?
So 11. That's 11.
Yeah, dx, right? So go ahead, make the substitution over here.
Uh, 11 to the other side.
Right. So we want 7 plus x to the 12. So that's u. Now I have x11 dx, right? So x11 dx is this, but I have 12 x11 dx, so I need to divide by 12. In that way, I will have x11 dx. That's what I need. So that will be du and 112, right? So basically, this guy x11 dx is this guy. So instead of writing x11 dx, I write 1 over 12 du. So that's what I did. So now I take the 112 outside and then plus c. I take 112 outside and I get 1 over u du plus c. So what is the integral of 1 over u? ln of u, yeah. So we'll get y squared over 2, 1 over 12 ln of absolute value of u plus c. But then what was u? U was 7 plus x to the 12. Mm-hmm. So we do y squared divided by 2, 1 over 12 ln of 7 plus x to the 12 plus c. And then we multiply times 2, so we get y squared and 1 over 6 and then 6c. So, oh, there you go, 2, I said 2c. That's just a constant, so I can call this a constant. So this is our answer. Y squared equals 1/6 ln of 7 plus x12 plus k. And that's what should be here. Ln of 7x plus 12 plus c, and that should be 1/6. Okay. Okay, so let me stop here Panopto, because I wanna. Sometimes these videos so long are not good. They break.